But if you understand what's going on with the fuel control unit, it makes it a bit simpler. This stuff over here really is strictly for testing. This connects to our balance machine, and so this is where we pick up prop RPM. This is where we pick up vibrations from the front half of the engine, and then the other one that's mounted to the back is where we pick up N1 vibrations, and this is strictly for testing. Okay. Components: N1 tach generator, and then over on this side is the prop governor. Okay. Now, the deal with the prop governor is when you're at feather and the ground idle position would align this notch with this lowest notch right here. Okay. Now, anything aft of there, you're actually going to be pulling into the beta mode. This little block we call beta block. Basically what it does, there's a ring that sticks out of the back of the propeller hub, okay?
Right.
And as you shift into beta, what happens is the part inside that causes the blades to rotate, it bumps up against the pins that actually hold this thing in place. So as the prop starts to reverse pitch, it depresses those pins, they're spring loaded, and they push this ring out and you get a beta indication, okay? And what happens is that transmits through this lever, okay? It goes down and it hooks up to this valve. So when you pull into beta, what you're doing is you're actually pulling this lever back, you pull this into beta, you open the ports that cause the oil to flow to the front of the prop hub, it pushes it back, and as it pushes it back, the beta block comes back, and this is actually a coaxial valve, so it's doing this. So when you pull beta, you command some oil to flow, and then as it responds, the other part comes around and closes the ports when you've achieved the amount of beta that you've commanded.
I got you.
Okay?
I got you.
This connection runs across to the back of the engine, okay? And it hooks up to this part, which is the reverse thrust lever, okay? This in turn is connected to the throttle cable, which is right here, okay? Now, the way this works, any motion on the throttle that moves this forward is going to push this lever down. It's going to take this and spin this clockwise. This is commanding forward power, okay? If you pull back, what happens is this hits this ledge, it pulls back on this lever and commands beta. So now the prop governor is going to pull, I'm sorry, the FCU is going to pull in the reverse direction, and you're going to get power up to full power going in reverse. And what you find, there's a pretty good sized spring on the end of that, and so getting into beta is generally a bit of effort. Once you're in beta, and depending on how you get everything, the tighter and the smoother your controls are, the easier it is to move. But the big deal is in beta, you're always pulling against a spring which wants to return the prop governor to fine pitch. Okay?
Oh, I see.
So beta requires a little bit of muscle. Okay, this is what we call the condition lever, or the fuel shutoff. Okay, and what happens is right now we're in the shutoff position, and to go into run, what we're going to do is we're going to run that lever forward. It's going to pull this, and it's just going to go past this little detent right here. Okay, and right there is the run position. Okay, this will give you enough fuel to get the engine started, and basically when the FCU is controlling your fuel, what happens is you can move this lever further out and so on and so forth, and as long as you're in this range, it's just going to allow the FCU to demand as much fuel as you want. But if you switch into what we call the isolate mode, okay, and the reason for the isolate mode is if something inside the fuel control fails, okay, and you discover that, you know, you have the decreasing N1, decreasing ITTs, power's going down, you apply more throttle and nothing happens, what that says is something's happened to the FCU. The idea is you return the throttle to idle because this thing is at idle, and now you turn on the isolate switch. And what you do by turning on the isolate switch is you turn this into an auxiliary throttle. okay? And
Right.
it shuts off all of the circuitry inside here that controls fuel, because it's more than just a fuel delivery device. It also monitors acceleration. There's a governor in here that governs top speed. There's a start circuit. All of that stuff gets taken out of the picture, and now you're controlling the throttle, and any movement from here in the forward direction is going to command more fuel, okay? The catch is when you're in isolate, this becomes very, very touchy. And so all your movements there have to be pretty small,
Right.
because all of the things that are in here to buffer the movements of the throttle are no longer in effect, okay? There's a thing in the FCU manual that says a part of the test says to increase the power from idle to full power over a 1 second period, and the acceleration thing in here should keep it from overspeeding or overtemping. Well, personally, I've never been brave enough to do that test, because if anything is wrong, you're going to blow up the engine. And so my attitude is this is not drag racing. We have no reason to put our foot in it.
Mm-hmm.
And so all power additions are always done in small increments, okay?
They just don't want it to flame out, probably. They want to see if it's...
Yeah, the question is well, here's the problem, okay? If you do command all this fuel, and that setting is not so high that it dumps so much fuel in that it flames out, but it's high enough for it to allow the fuel to grow too fast, you're gonna soon get into an over-temp situation, and I would rather not risk that.
Right,
okay?
right.
The idea is let's stay in control.
Yeah, you know, you've got a good thought there.
Okay, these ports over here, these actually hook up to the fuel return. We hook these to what we call an EPA can.
Mm-hmm.
When you shut down the engine, a small amount of fuel pops out of here, out of this port, and out of this port. And this one is on the FCU, this one is on the fuel pump, okay? Mm-hmm. And what happens is all that does is it relieves the internal pressure. And so you might get an ounce of fuel in here, okay? Now, this over here is the switch for isolate. This up here is what we call the EHT, okay, the electrohydraulic transducer. And when you're in the start mode and the engine is spooling up, when you apply power to this, what you do is close the solenoid valve in here, which limits the amount of fuel, okay? Now, the catch is, if the throttle is not on, okay, and if you notice we have a little protractor over here.
Right.
0 is this position, okay, that's the center point between forward and reverse. If the throttle has been advanced, and this thing is down here, it's going to command fuel. The EHT cannot override this command of fuel. It can only override when it's in, you know, when it's approximating the idle position, okay? So the first thing before you start the engine is always pull the throttle back to the beta gate, make sure you're in the idle position. This is how, remember I told you the one yesterday about the gauges going off? That's
right,
exactly what these guys did. They had the throttle popped and they pushed the start button. Bingo, it starts up, it fires up. Now the FCU takes over and it starts dumping fuel in there, and this thing just went completely out of control. So the idea is the EHT is controllable by a push button. You'll have one on the panel. Mm-hmm. Our start module does not do any limiting, and it keeps the pilot in the operation.
I got
okay? So that's where that happens. Now, all of the fuel delivered to the engine goes through this tube. And this is how it gets into the manifold, mm-hmm. okay?
Right.
So it goes into the slinger ring, fuel gets delivered to the engine. The torches, on the other hand, okay, this is your spark plug, what we call the igniter,
right.
And then this is the torch fuel supply. This fuel actually comes directly from the fuel pump, okay, and the only time that it gets actuated is during the start cycle, okay? So what happens is when you go into the start mode, the start module actually controls several things, okay? If you say start, okay, what it does is it turns on a 20-second timer. That 20-second timer now takes control of another relay that controls several other circuits. So what it does is, first of all, it spins the starter. It's going to spin it for 20 seconds because generally a start is going to be completed within 20 to 30 seconds, mm-hmm. okay? The second thing that it does is it sends fuel to the torches through what we call the interrupter on the fuel pump, okay? And what that does, that just allows fuel to flow into these tubes. That is hooked through another relay that turns it on for a second, off for a second, on for a second, off for a second. All the time that that's happening, the other thing that it does is it sends power to the exciters, which are the black box that make the spark. The spark plugs are going tick, 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 making spark. As you shoot fuel past it, at some point it reaches a stoichiometric mixture. It ignites, carries flame into the combustion chamber. The engine is delivering fuel. That whole thing pops and you've got to start. The last thing it does is it delivers power to the EHT, so you can control the start. Okay, so you've got starter, the exciters, the interrupter, and the EHT are all powered through the start switch. If you go to cold cycle, okay, what happens is we still spin up the starter, okay, but none of the ignition events take place. We don't fire the spark plugs, we don't send fuel to the torches, and we don't power this guy. So consequently, the only thing that's happened is you're spinning the starter. The reason for a cold cycle is you never want to start the engine if the ITTs are anything higher than 150 degrees. So it's all about pumping air through the engine, bring down the internal temperatures. Once it's below 100, go ahead and do a start. Okay, we'll do all this stuff. That's really about it. Okay, this is that pop-off valve I was telling you about. This guy over here closes by 90%. Okay, so what happens is prior to 90% on N1, this thing is passing air. Once you get to 90%, this is completely closed, so all the air coming from the compressor section is being delivered to the turbine. Okay,
Got it.
let's go and push some buttons and move some levers and do some stuff.